Hello, everyone. Hi. Welcome to yet another class meeting of ECS 179, Gameplay Programming. I just want to make sure that OBS is recording audio. Okay, great. Let me turn the gain down just a bit since we're going into the yellow. Gain is that way, not the other way. Cool, cool. All right. So today, we are going to explore Exercise 1, which has been released. So first, I would like to apologize for getting it out. I was hoping to get it out by Friday, but I got pretty sick over the weekend. And basically, all of my cognizant mental effort went into getting this to you, and it ended up getting in a little after midnight last night. So please check it out. The due date, we're going to give you until midnight anytime on Earth on next Tuesday, the 22nd. So I'm giving you a little over a week, give you some bonus hours, but I hope you don't have to use them since they are bonus hours between midnight and like 8 a.m., which, given computer scientists, may be the most productive time. Huh. All right. Maybe that's not a bad thing. So this exercise is on GitHub Classroom. So please check that out. Make sure you click the appropriate email address when you open up the assignment. We've had a couple of people that have chosen an email address that was not theirs and bound their GitHub account to someone else's UC Davis email address. So I put all of your email addresses in the list, all of your UC Davis email addresses as provided by the photo roster, so the official roster. Find your email address in the list, click on it, and start the project. I recommend, if you have a GitHub account, to do two things. One, sign up for the GitHub Education, the student pack. It's really nice, gives you a lot of freebies. Thanks Microsoft for putting up money to do things for us. I don't usually thank Microsoft, but this is one instance where I will. And the other is to make sure that, GitHub is social. And like any of your other socials, you want professional and maybe private. So if you're contributing to manga ripping apps, and you don't want that to be your professional face, maybe make another GitHub account. Make sure you associate your main GitHub account that you want professionally with your UC Davis email address, but keep your private email address as the primary, because we all know your UC Davis accounts go away after you graduate, which is a bad move. I don't like that they do that. But in this case, it'll help you out. We need to bind your GitHub account to your official student roster for ease of grading. If you have problems with that, let me know. If you need an alternate arrangement, we can maybe do some special cases. We just can't have everyone do special cases. Just a quick check. Who has used GitHub Classroom before? All right, so that's a good amount of you. So if you know people who are in this class who have not used GitHub Classroom, maybe help them fork that first repo. Also, there's also a bug with GitHub Classroom. Don't cheat. Please don't cheat. It's one that we found here in some of our classes, so hopefully that'll be fixed soon. If you've taken any security classes, you may have found this. All right. As a reminder, you should turn in your assignment, your fully fleshed out, completing all 4 stages assignment. You should have that turned in by any time on Earth midnight next Tuesday. It should be on the auto-generated repository. It should be, basically it'll say exercise 1 or command pattern exercise 1 command pattern dash or underscore for which one it does, your GitHub username. That'll be automatically generated for you. We will be looking there. It'll be part of the Ensemble AI repository, since that's an organization I own that I use for these sorts of things. You should then make sure that all of your code that you want graded and all of your documentation, everything that we need to see, is on GitHub in the main branch in that repository. That'll be the thing we grade. That'll be the thing your peer reviewers look at. If there's something that you want us to know, put it right at the top of the README, right before the assignment description, that main README, just big old bold, we can't miss it right there. So when I will direct you, we'll talk about peer reviews next Tuesday. I will direct you to look at that. I will direct you on how to do the peer reviews, and the graders, the TAs, will look at that area as well. Right, so there's a lot of room for you to do interesting, cool things, and we want to make sure you get credit for those. This class is about gameplay programming, and that ends up being a more open creative endeavor than most of your other programming projects. So we want to make sure that we account for that make the spirit of the class true to the spirit of the profession. And that necessitates communication. So let's communicate. Okay, so did you have a question? Yes.
So do we get points off for wrong coding style?
We're going to take it easy on that on this first exercise. Yes, in the future. Now it'll be marginal and minimal. That is a goal of the class, is for you to learn the practice of programming in this space, which does involve style guides. Now, if you do things wrong on this first one, that's actually not a horrible thing for us all. That way your peer reviewers have something to peer review. So I'm not going to be too much of a stickler. And you'll see that in my fever dream, Halloween-filled sick state, with probably too much cold medicine, I may have actually made some style guide infractions myself. I haven't done a thorough check. So there may be some code in there that is not consistent with style. I will try and correct that as much as I can, and all the typos that you'll see, including the version that I posted last night that I accidentally put Unity instead of Godot in the first sentence of the assignment description. That is now fixed. If you pulled it last night, it'll say Unity. If you pull it today, it'll say Godot. There's no functional difference for your grade for those projects. It's just in the assignment description. All right, the assignment description that you will follow is in the README. We're going to do a thorough look at that during the discussion section today. So I want this class lecture portion to be about the project so you can understand what's going on inside of it, the technical decisions that we made, the command pattern, etc. I want to give you the basic understandings of what's going on in here. And then we'll talk discretely about the assignment, its structure, how to turn it in, bring your laptops to discussion section, and we will make sure you can all get started. Okay. I'm kind of excited about this. Last year, it was a pirate-themed motivate your other pirate adventures. This year, I went a little more spooky with it. Has anyone played it yet? All right, we got one person. Shall we play it now? I'm playing the key. Let me make sure I am playing the key. Okay, yes, I'm playing the key. All right, I'm going to turn off the microphone here for just a sec, and we'll just play through the game.
I shall reap what I sow. Isn't that the saying? Embrace the shadows! The prey approaches. How uncharacteristic. Not unwelcome.
Defeated the tortured spirit. All right, so this is a little mini experience here, right? So we have, start here. So what we have is a new character, the player, unnamed as Jack. It's elf running. The voice acting was taken from Creative Commons voice acting. Skyrim mod where they added extra characters. This character's called Thorn. It is in full attribution for all of the art, all of the sound, all the assets that I used. So it's all Creative Commons or freely available work. Either your tax dollars paid for it or someone provided a Creative Commons license. You can find those in the various text files within the assets folders. We have movement, we have jumping. We have hitboxes, we have hitboxes. We have 2D positional audio effects. So you can get and then we have upstairs, we have a follower that's following us around. Something whenever we are above its certain amount.
The prey approaches. How uncharacteristic, but not unwelcomed.
Alright, and that's what the script is. Now we also have the hitbox, hurt box on the boss.
Yeah!
Running noise.
Yeah!
And what we're doing is percentage of the boss to pitch bend. So we're actually changing the pitch bend.
Yeah!
Plus
Yeah! Yeah! Yeah!
So a little bit of spooky Halloween stuff, right? One thing I want to show you, and this is useful for your own projects, is if you go to debug, you can view collision shapes. And so now you can see a little bit of what's going on under the surface.
Embrace the shadows!
Oh, and there's cheek hands.
I never tire of this.
And your version will tell you what so key is teleport. But you can see things are now shaded. And so there's a shaded box around the character. You can see there's an unshaded box right here when I attack.
Yeah!
As it becomes shaded,
Yeah!
it starts placing the enemy.
Yeah! I shall reap what I sow.
The clouds are shifting.
Isn't that the
A storm
same?
approaches.
They do their scripts upside
Embrace the shadows!
and you can use the trigger circles to start the boss fight.
I will make you wish you were never born!
And now right, so all this is just combinations of stuff we've kind of seen before, but I want to see how you contextualize all of this during gameplay so that we can go and look at these. Because there's a lot of things here that you might get there's something like around 30 scripts in this project, a lot of assets, a lot of game objects, cuisines. This is meant to be a vertical slice. So you can see this is a lot of mechanics, a lot of things that are here working at a base level. You could easily just take these assets, take this space, and build a bunch of levels from it, right? This is the core implementation. You can build a much larger game. It's got sound baked in, it's got animations baked in, it's got state machines. Configuring scripts for things. The hard to get there, the hard to assign. All right, so let's start at the top. So first thing when you open this, usually Godot starts in 3D mode, so you'll actually see this. So make sure you open up main. So the main is in the base folder, the main scene. The sub-scenes or the other scenes we use are in a scenes folder right here. And is that too tiny? Can you see these things? You good? Okay, thank you. They're very tiny for me, but they're very big for you. All right, so we have a bunch of scenes. We have boss, character, dialogue box, follower, player, and poison zone. So here in our main scene, we have things that you would expect. We have 2 tile maps. We have one for the ground, and then we have one for trees. The reason there are 2 tile maps here is one is actually the tiles are twice as big as the other. And that was to scale the tree to be an obstacle big enough, or a tree that looks like it was at least big enough to block the character. And we could scale this tile map to make it even bigger if we wanted the tree to be larger. So you could go to scale, and we could just triple the size of the tree, right? Ooh, no, that's too big. There. And then we can move the whole thing around to just make a much larger tree. And that would still work because the collision surface is tied to the tree. I didn't bother sculpting the other side. So you can see the collision surface is on. So we have our 2 tile maps. And just like some of the tutorials that you saw, we made sure that we did collision surfaces on the tile maps on particular tiles so you can see what's going on. So the 2 tile sets we have to work with. Turn on the mouse resolution a bit. There we go. This border is very finicky to find. All right, so we have this tile set, which is basically ground, grass, trees, that sort of thing. And we have a village tile set, which we're basically just using this tree for. And some of the grass. We have a player object, which is fairly complex. It's its own scene. This is an instance of the scene. You can tell it has a unique name. So we right-clicked and used it as a unique name. We gave it a unique name. We can revoke it if we'd like. So that means we can refer to it, anywhere in our project through the %sign. It emits signals. You can view its scene with the scene button. It has a script attached and is visible. We have a boss. So I should note boss, follower, and player all inherit from the character scene. Right, so there's a common core of being a moving, controllable thing in the world that we wanted the implementation of. Now the character, boss, and follower specific details are in their particular scenes. The character, let's look through here, then we'll dig into that structure because it's a little more complex. We also have a boss encounter surface that is, this is an area 2D with a collision 2D surface inside of it. And it has a script that looks for the collision with the player. It starts the boss scene, starts the boss encounter. We have a boss camera location. So this is the location that the camera gets pegged to when the boss fight starts. We have the camera itself. It has a very simple script. Oops. That simply lets us that simply follows whatever object it's targeting. So it has an exposed exported target value, which then you can then set. Now it follows the target's X location, doesn't follow its Y, so it's not following all the details of the jumps, but it does, when set the common Y position at that portion. So if that little node, the boss node, is moving, the camera would follow it. It has no capability to do so. So a very simple camera. We also have a dialog box associated with the camera. It's a very simple dialog box. You can use it for text. You can make it pretty. I made this in like 3 minutes just to have some text on the screen that looked dialog box-ish. It's not particularly well styled for the environment, but you can put whatever you want in there. And that is pegged to the camera, so it's always visible. It's in the camera space. We have a parallax background, which is, as Armpreet described, this Genshin-esque background that takes care of parallax concerns and continuously scrolls. The parallax effect is very light.
I never tire of this.
You can see the parallax Parallax is built into Unity, so if you go to the parallax layers, you can change the parallax values by changing the scale values that it has. So that's the scale of motion between it and the things around it. And it's scaling the sprite 2D, which is this image. All right. And we have a world environment. This allows us to have things like lighting. So you'll see there's a light object here, a point light, that lets some of the light come in and modifies how you see the surface and the shadows and things going into the cave. It also allows us to do the environmental lighting around the poison and the little point light on the eye of the boss. All right, and we have a directional light 2D, which is the sun. We have a poison zone, which is a little area that we put around this few plants, this little obstacle that we have that makes the bubbling noise as well. We have an audio stream player, which is playing this environmental track, which is, okay, I guess it won't let me play it from there, which is what you hear, the 5 or 10 minutes, I guess the 490 seconds of park noise. I guess we had to jack the volume up so much that normal volume, you can't really hear it. I have to make sure I fix that before I go to my office. All right, so the audio stream player does that. We have a little script attached to it, so we can just configure where it starts. Since it's environmental audio track, we want to start it at a more juicy spot, which is 45 seconds in for us. And we have our point light 2D, which is this light that we bring in from the outside. All right, so that's the basics of the main scene. You know, this is a high level. We try to keep our high level scene fairly clean, right? It's got the basics. It's got the world, the things that move in the world, some triggers that help us manage the world, you know, camera locations, a camera, the background, a world environment for lighting, some lights, a poison zone, and audio services. All right. So let's dig in here a little bit. Let's look at the character. So if we open up the character, what you'll see is fairly bare bones, right? There's no graphics here. There's a sprite 2D, but it has no assets associated with it. This is like an abstract class. This is an abstract set of capabilities for things that are characters in our world. Now it has an animation player. It has a collision shape. And it has a sprite. So these are some basic things that all of our characters need. Our character body 2D, it is the root node is a character body 2D. Does anyone know what that does? We've had a few of them. It's a bundle of capabilities. What are these capabilities, I put to you? Oh, I have to remember the tutorials now. No. Yeah.
Check if the character is on the floor.
Yeah, it has basic physics, basic movement. It hooks up to the process signal, which allows us to use delta time to do time-based effects. It gives us the capability of a rigid body, right? So we can enact and interact with the physics system. It gives us the ability to set our collision layers so we know which types of objects in the world can collide with us and which types we care about colliding with. It has the basic position, the basic capabilities of a node plus a rigid body together. And an animation player allows us to play animated sprites. And we configure, well, an animation player is actually very broad inside of most systems. There's no exception in Godot. The animation player can actually animate or change over time any property value, whether it be a bool, a string. It can call functions for you. It can change values, including change integer values at regular intervals. And with our sprite takes a sprite sheet. It has a set of frames in it after we configure it. And by incrementing the frame counter on the sprite sheet, we can then change which graphics we're currently looking at. right? So that's the basics. We'll take a look at that when we look at the character, and I'll show you some of the animations for it. We have our character body 2D, the core node here. It has a script associated with it. This script has a few things going on. First, it's class name character, and extends the character body 2D. So that we can have access to all of those things we talk about. We have a signal, so character direction facing. Because we're not just flipping a sprite, we also need to flip the collision surfaces along with the sprite. We had to do something more sophisticated than flip H, right? And so this helps us. We have a set of scripts that help us do left and right offsets, and we emit signals from this character to allow these scripts to know when directions have changed. Since the script handles the physics and knows which direction we're facing, all the other things should respect this core logic inside of this script. Which is why we also have an enum called facing with left and right. So we can just pass around that enum and everything knows, it's very clear what things are. No negative means left, positive means right stuff. We're directly making representative enums for those. And we have things like some constant default values for velocity and jumping and moving. Terminal velocity, so you can't do the moonfall from Super Metroid. And then we give some default values to movement speed, run speed. We have a set of commands. So move left, move right. When you press W or up key if you configure that. We have fire 1 and fire 2 and idle. All these are commands. And we've looked at the command pattern, so that means we can instantiate things like move left, move right, jump, attack. All those are commands that follow that same interface. That if you look in the assignment description, there's an execute function that takes a character and returns a status. So we'll take a look at that momentarily. All these fit this paradigm. So that way you can reconfigure these actions on the controller to be whatever actions you want in game. If you want jump to be bound to left, more power to you. And it's kind of handy, like when you get a dazed or confused effect, to scramble those control patterns. Common thing to do. All right, and we have attacking here. I want to give you a couple examples of making built-in getters and setters. So here are a few. We don't really use them, but they're handy for checking values that are incoming and outgoing. They're good for diagnostics. I put these in because I was testing some animation values and I want to know exactly when the character received the information to start the attack. Therefore, I could sequence everything such as the sound and the animations accordingly. So I just wanted to see when information was changing. If you overload your getters and setters, it's easy for you to do that. Pardon me, my voice is still a little rough. Hopefully we'll make it through class. All right, and summoning, that's when the character spawns. There's a little bit, I was changing terminology between summoning and undeath here, so you'll see a little bit of both. Also a control variable for jumping. We have the physics properties for basic 2D physics. So you can make stylized physics as much as you'd like, and you can make those a physics style. And you can set those in the project settings. But here, we're using a default, and we're just snagging it for the project settings. So if you change the gravity value in project settings, our code can know about it and use it, and find those values and use them accordingly. Horizontal input, we're managing some input with that variable, and we have some on-ready things. So these on-readies are typically in this project, things you can publicly access. So let's say you wanted to call the animation player from something, from some script. That means everything that is a character will have a publicly accessible animation player. Notice that these are bound to what's in the scene. Right, so this gives us basic capabilities to alter the things that you inherit from the character. And then we have an initializer, so we make sure we have the facing and all the states set as we'd like. We have broken down the physics a little bit to apply gravity and to apply movement. So you can see how we apply gravity and apply movement separately. I usually leave these separate because they're very handy if you want to do things like double jumping, if you want to have anti-gravity, if you want to do dashing. Breaking them up into this helps you find those places where you need to put in those different physics commands. So this is just a future leaning thing. It's not super necessary now because you could just call move and slide and you could set velocity y within physics process. But best practices. Move. So for, if we wanted to externally move the character through some force, we have change facing, which simply when we move left or right, sends out the character direction change signal that we defined above, and anything that cares about that, like the collision boxes, the collision 2D volumes, they'll react to it. Then we clear our state, and then we have this command callback. So when a command happens, we want to send the information back to the character to note first that the command has happened if there's any back accounting we need to do. And second, this is critical to doing things like managing the sound system. All right, so there's a lot going on in this script. You should take a look at it. You should be familiar with it because you're going to rely on some of its capabilities when you particularly do stage 2, which is make your own controller for the follower. Okay, let's take a look at the player now. All right, just checking the time. All right, so the player is probably the biggest script. It has a lot of things in here that you may want to look at and know about, but there's only a few places in here that you'll be required to manipulate and alter. So first, we have health. Right, this is a thing that can be hurt and hit. We want to know when we receive damage or when we're dead. We also want a reference to our animation tree, which helps us control our animation states. We have a ready function where we do things like make sure the animation tree starts is active. We want to bind all the default player commands. And we command callback undeath. That's the thing that starts that first animation.
The clouds are shifting. A storm approaches. The cold hands reaching for me.
She has the capability of resurrecting herself
I never tire of this. I detest the taste of my own blood. You'll pay for this.
Try again.
I never tire of this. I detest the taste of my own blood. You'll pay for this.
So sending that undeath signal calls the command callback, and this command callback handles several things for us. We just take a look at that right now. This command callback, it plays the audio clips for us based on what's happening. So when you attack, it plays the audio sound manager. Same with jump and engage, which is when you engage the boss, and undeath when you resurrect yourself. All right, so you can see that it's reacting to these external events. It's a very reactive class. The physics process is a little overloaded. So first, if you're dead, return, which is a little confusing because you're not returning from the dead. You're just dead returning. You're not interacting with the physics process. Everything's short-circuited. Then we have, we're getting the input direction. It is formulated in this way because you can easily use this with controllers as well. And we do the subtraction, so that way we know we're moving left and right, and we can configure our own dead zone by being non-reactive to small values within that space. right? So we have jump. Actually, you got a little preview. That was a little code I'm going to have you write for part of the first stage, but you got a little version here. Let me open up the key, or not open up the key. I'll open up the project that you will see. Is there a question? You said you're... Okay. Okay, that is not the key. This is the key, not the key. Engage. All right. Let's get back to the player. Okay, so first the differences. I can't jump. I didn't bump up the sound, so you can't hear much. Oops. We can't attack. Yeah, that's how much I've had to bump up the volume, right? The follower does nothing. He can still die
The
and resurrect.
clouds are shifting.
Cold
A storm
hands
approaches.
reaching for me.
And the boss battle
Let's
still
see
goes.
what you've got.
Let's open up the player. Let's open up the scene. And the major script. And make it a little bigger. All right. So we have this. Hey, stage 1, handle jump input commands here. But you can see how we handled fire and attack and moving left and right. And then we want to make sure that we call super with delta in it. Why are we using super here? What is super? Those of you who know object-oriented programming, what is this doing? Why is it super? Thanks for asking. Yes.
It's calling the class that we're extending from.
Yeah, it's calling that same function, the process function from the parent. Right, and so we're passing delta to it. So all that physics stuff that we handled inside the character class, we're just calling that directly. Right? That's why there's no move and slide and no gravity in this particular class. We already handled it. And then there's manage animation tree state, which is a little bit of state information to help us manage our animation tree, which we'll look at. Okay, so I want to stop here and look at the project settings. So this will be important. We'll ask you to manage this a little bit for stage 1 of the assignment. And we have the input map. In the input map, we have move right set to D, move left set to A, attack set to left mouse, and jump set to W or space. We have cheat 1 set to R and cheat 2 set to T. Do with those what you will. And so those had discrete names, like attack was set to left click, right? So that's exactly what makes this attack string meaningful. And Godot is smart. When you call this is action just pressed function, and you start putting in, and you start wanting to fill in the parameter, it'll give you all of the things the input manager knows about. Right, so it's easy. It's a little harder to make mistakes. So attack. Move, move, move. Notice that when we fire, we execute. We call execute. And we pass self, right? So all of our commands require a character. We'll look at that execute in a little bit, but they all take a character. Typically the character that you want to perform the command. That structure is handy because you can use it here and execute on yourself, but if you have a larger script that say you want to control a cinema scene or a cutscene with, you can make a whole bunch of commands and target whichever character you pass in. Right, so it's got some dual purpose here. It's the structure that it has. And we're not doing anything with the return values with the character. When you're dealing with direct player input, things are immediate. You make the player make the decisions. The player controls the timing and tempo of how the character moves and feels. When you're dealing with NPC script, you actually want the attack to take attack time duration. You want its animation to complete before you move on to the next thing. They have duration, they're durative. So we'll look at how that works as well. We have a take damage function. So we'll look at how this works. This is called from the hit box. I'm sorry, the hurt box. So you can take damage when your hurt box is hit by something that is a hit box in this setup. So first thing we do is take some damage. And we set our damage state to true. That helps us trigger through the state machine, the animation state machine, the hurt animation. And if your health is less than or equal to 0, you dead. So we play a defeat noise. And this is structured in a particular way. What we're doing is actually randomly playing from a playlist with weighted random properties. So there's a few different defeat noises that we have, and we let it select one. We are dead. We stop the animation tree because you don't want to be moving left and right and changing your animation when you're dead. And we play the death animation, which is simply the summon animation in reverse. Otherwise, we're just hurt. So we want to play the audio for being hurt. And you can see the audio script. There's an audio player for each one of these. Let's just look at hurt. And you can see it has an audio stream 2D, which means it's 2D positional audio. Inside of here, we have a randomizer, a random stream player, and we just give it a bunch of streams. So these happen to be the 3 sound clips that are in audio player hurt. So we play and pathetic and obviously I'm a voice actor. Right, so it just helps us randomly choose between those, and you can bias the random with the weights on them. You can set it, interestingly enough, you can do random, so it just is true random. You can do random without repeating, so it'll do everything in the playlist once before repeating a second one. And sequential, where it just goes through the list, not random. All right, so we have for attack, jump. The ones for jump and attack are interesting because the randomness here, the random player, we actually have a random pitch bending and a random volume. So it can be between a boost between 0 extra decibels and 3 extra decibels louder, or the pitch can be bent up to 9%. Higher. So there's a little bit of variation in the attack noises. They're not just the same one over and over again. So this is where you can use procedural qualities of a system to give yourself a little gameplay variety kind of for free. Okay, so let's take damage. Here is our manage animation state. So this is handy. So this is a good function for you to know, because have you ever tried comparing a float value, radix float, to a 0? It's tough, right? It's hard to get true 0 with your floating point values, with just the way that data is encoded, with the exponentiation and everything. So there's a handy-dandy function provided by Unity and by Godot and the Vector 2 and 3 classes called is0approx. Right? So is it close enough to 0 to count? And you can look at the documentation to see what those thresholds are, but we're using it here. So if you're basically not moving in the X or Y direction, then all right, so if it is not 0, not approximately 0, then you're not idle, but you're moving. So what we're doing here is we're setting flags in the animation tree. And we'll take a look at it in a moment to see how that works. But we're just giving it a little bit of information so it knows how to triage a small state machine. So if the movement is approximately 0, you're idle and you're not moving. So those are mutually exclusive values, which we'll get some warnings for. But we're handling it external. And on floor, so we want to know when we're on floor and when we're jumping. So if we're not on floor, we want to play a jump animation, so it'll look like we're in the air. And if we are on the floor, we want to make sure we're not playing the jump animation. And then we have some toggles here. So we want to know when attacking starts, so we can start playing the attack animation, and the animation tree will handle making sure the attack animation plays through its duration. And we don't want attack to keep happening over and over again, and we're relying on button presses to handle this. So unless we want to put some state information inside the animation player itself, which isn't a particularly good place for it to go, here we're just having a toggle. Once the animation is initialized, so we're setting attacking to true, which will be picked up by the animation tree. We're setting it to true. That attacking value, we then want to immediately turn to false, because we don't want to trigger multiple times and make the attack animation stutter. Same way for is damaged, which is great because now you can see if the animation is playing And you could give it iframes. You could have, you could, in that take damage value, you can see if the damage animation is playing, the deferred animation is playing, and if it is playing, don't take damage. Right? Classic iframe stuff. Get ready for bugs. Make sure you take the boss's small attack damage so you can just like walk through with big attack damage. All right. And then we, have the same toggle, damaged and attack work the same way. And then we have two functions here for binding the input commands to the player. This first one binds the default input commands. Move right, move left, blank command, because what does up do? Well, up jumps, and you have to make sure they handle jumping for stage 1. So you probably want to put something there. Attack and idle. And unbinding. Why would we want to unbind our commands? Yeah. During the cutscene, like anytime we want the character not to be controlled by the player, we can just simply unbind these commands, so whatever player input happens, it just gets sent to a blank command that does nothing. Here's our resurrect function. It makes dead false. Yay, we're alive. Sets the health back to 100. Re-enables the animation tree. And plays the undeath animation. Calls the callback so we get the sound for resurrecting, get the call out. And then we make sure to get the state machine and make sure we set it into the initial state. We're basically restarting the animation state machine, so we don't have any funky artifacts. And then we're back to our command callback. So we've almost went through this entire class now, right? Now you can see like there's a lot here, but each one of it has like a real purpose. And then here we have an animation player. So this is handy. So like if you spam the attack button, or you spam movement or resurrection, we want to make sure that if that audio service is already playing, we don't just restart it. Right, so that way, if we resurrected a bunch of times, you wouldn't get a bunch of overlapping voice lines. So just a small check. All right, so let's take a look at the animation system. So first is the animation player, and you've seen animation players before now in Godot. Gosh, why is this surface to make this thing go up like so tiny? Oh, because I'm looking in the wrong place. It's very finicky. All right, so we have our reset. What does reset in animations do, for those of you who watch tutorials? Any animators here? Yeah. Yeah, reset gives it like a default place of being. But it also, because this is a system that can handle basically any parameter value and change it over time, we want to make sure we can set some defaults. So here, what we have are setting it to a default frame. So the first frame of the idle animation is what resets to. But it also turns off the attacking collision shape and makes sure that it's not active. Right? So just a simple check to make sure that we're not walking around with a live weapon invisible, right? And then we have attack. So you can see here, there are a few things going on with attack. Ignore this. This is a little bit of debugging I was doing. All right, that's a little better. So now you can see, let's go to 2D. Let's stop. So the state machine is actually running right now. Animation tree. Let's set you to end here. Animation player. Animation. Okay. Right, so here's attack, right? Just a few frames of attack. Wait, where aren't you actually going? Our animation tree. Can we just turn you off? Okay, great. There we are. Reset, attack. Right, so you can see we can go through and look at each one of these frames. And notice when we start slashing, we turn on the hitbox. That's what these keyframes are down here. So there's a disabled Boolean associated with collision shapes. So what we're doing is simply adding that property as an animated track. And we start with it turned off. Disabled is true. But then, once we get to the beginning of the slash frame of animation, we set disabled to false, which means it is enabled, which means it is active. And then we make sure that it's active for exactly, these 3 frames, or these 2 frames. And then it is not active anymore. And we say frames, it's not the same as like frame-based animation from old school games. These are sprite frames, but we can arbitrarily run them at any speed. In this case, each one of these are 1/10 of a second. So they're basically 10 FPS on these character models. We just load in the animations to make them feel a little impactful, a little more juicy. And so we turn it off. Attack animation. We have our death animation. I guess I did make 2 of these just for use sake. We have fall. It didn't actually implement fall because the jump was good enough. Hurt. A little flashing and bouncing around. Not super happy with that one, but it does the trick. Then we have idle, which is set to looping. Jump. A few frames of up and some frames of down. And we have our running animation. And summon, which is backwards death. Right, so we have these animations to work with, but how do we use them? We didn't have any way of like really sequencing them and saying like when should you go from one to another. We set some state, and we set that state to the animation tree. But the core of that logic is actually down here in our animation tree. So we have a state machine. Most of you have dealt with state machines before. You may have used them to recognize letters to see if they follow within a grammar or a language, to see if they are acceptable within your specification of like a regular expression or something like that. Maybe you've like even thought about the pumping lemma, and thought about how languages, grammars can set languages, state machines. Well, here we're using this for a game purpose, right? If you see here, we have each one of these. I can't actually make this any larger. Darn. Each one of these are the names of an animation. Summon. Idle. So now you see how it's sitting here in idle. So if we just start initialized, it summons, and then goes right into idle. We have jump, attack, move, and hurt. Right? All these are interconnected with this like nest of one-way connections. Right? So each one of these is a transition, and each transition has properties. So these transitions, such as summon, this one is set to trigger at the end of the previous animation. So as soon as the summon animation is done, this transition is immediately taken into idle. And then idle will transition into move when the moving condition is true. Well, where does that moving condition come from? We saw it earlier. The moving condition is right here, where we're checking the velocity. If moving is true, that is the condition that directly is checked right here. So if you're in the idle condition and moving is true, you transition to move. This is why I make these mutually exclusive, because you can actually go into the tree here. And you can look at all the parameters that you set. You can see all of the conditions that it knows about. And let's say, let's go back to 2D here. If we have moving on, it's running. But if we have moving and idle, two mutually exclusive conditions, right, it immediately does the transitions every frame. Same way with on ground and jumping. Right, but you can play with it. We can be idle here. So what happens if we get a jump command when we're idle? Well, we jump, right? And we keep jumping. When do you stop jumping? When the body hits the floor and you turn jumping off. If you're jumping on and not on floor, you're in jumping animation. Even if you're jumping off, you're still like in the jump animation, it's just not regenerating. And then you hit floor, transitions back. And you can see this directly in this transition. You can see that the switch is set to immediate and the condition set to on floor. Right, so this, maybe you're getting an idea of how we built this machine. We don't want to go through the entire thing. We don't have all the time in the world, but you can see how this is very handy for us keeping basic accounting of animation properties. You know, def is outside because we don't want it immediately transitioning to anything else. We manually make the transition back to summon when we hit the R command, the cheat command. Now, part of stage 2 is your follower will be able to resurrect you on a 20-second cooldown. So you're going to have to figure that out. Luckily, there's the handy resurrection function on the player, so you can do the math. Hurt immediately goes back to idle or whatever the transition is. So you can see all these are active. The big things are say like summon and attack. We make sure that those animations always go till they end, because we don't want to like attack and then have like you moving left while you're attacking, like interrupt the attack animation, and therefore your attack doesn't go off. I mean, that would be a difficult game to play, right? If you had to like not touch the directional pad or the thumbstick at all while you were doing the attack animation. So we made that uninterruptible. You can still move left and right while you do it, but the animation and therefore the collision surface is enabled while you're moving around and jumping. All right, some things there. Did you have a question? Yeah.
Back to the like frames, or like the animation frames.
Mm-hmm.
Are you able to like transform, like let's say for the attack frame here, are you able to transform the like attack hitbox while the frame is playing? So like as you're swinging the sword, like the hitbox follows the sword, I guess?
It does that. So because the hitbox is a local offset from the character,
Right.
when the character moves, the hitbox moves as well.
But like when you run it, right, you see how like there's the swing, so it like the hitbox will always match the swing no matter what.
Yeah.
I guess.
Yes, you can do that. What you would do is, let's go to this frame here.
Yeah.
What we could do is make a new track. And so we go to properties. We can use the collision shape. Let's see that we want the collision shape for the hitbox. This one right here. And then we want to find its position. And you may want to do rotation as well. We're just going to do position, so it won't be fully correct. So here we want to insert a new key. Did I just do this? Oh, that's because I did the function. It's right here. I did the wrong one. That character byte, you can call arbitrary functions with this as well. So we're going to insert a key. And so what we're going to do is now click on our sprite. We want to set it, take it to the position we want it, like right up here.
Yeah.
Insert the key. And so now when we play this, well, it will move the key. We need to find a, we want to move it back.
Yeah.
Like let's say we'll do this second example here just for, I guess we'll put it right here in the middle of the sword. We know it's not scaled properly, but this is just an example. Insert a key. That's not what I want. I just simply wanted to play the animation. Right? So now you can move the hitbox. And it's actually set to interpolation, right? So we actually want to set it to be discrete values instead of interpolated values. So that way the box just doesn't slide from place to place. It just pops. Cool. Yeah, so there's a ton you can do with the animation.
It will like be enabling the same way with the disabled like, keyframes.
Yes, exactly. Yep, exactly. It's when you start tracking a value, it puts a little key next to it when you look at it in the inspector. It makes it really easy just to tap that value and it's inserted. It's kind of a slick system. So we'll just disable that for now. Actually, let's just get rid of all those things that we did. Okay. Let's not shoot ourselves in the foot. Cut our own foot off. Great. All right. So that is the basics there. We have a hitbox and a hurtbox. Let's cover those real quick. I think we talked enough about animation. If you have any questions, I'm happy to help. But now you know how this is going. So if you want to add your own animations to, say, the boss, you are more likely to be able to do that now. Oh, I guess one last thing to add is with the animations, with the frame-based animations, if you want to add, so there's a lot in our sprite sheets that we didn't use. If you want to add those into your own command, you can add your own sprite 2D frame property animator, track animator, and you basically can go into your sprite 2Ds And now the actual frame values here, you can insert keyframes, right? And so, we have a bunch of frames in this sprite sheet. Like there's ability to hang on walls, and a set of frames for climbing. So you get there. Death. Oops, I'm actually down instead of up. There we go. Jumping, climb, hanging onto a ledge, falling, crouching, running. There's a whole set of attacks, dash, and then climb. Right, there's a lot of stuff we haven't used yet, which you could use. Basically, it's just make sure you put the right frame value inside of each one of these frames. Okay, 15 minutes. Woo-woo. Okay. Let's take a look at hurt boxes and hit boxes. So first, let's start with the hurt box. So the hurt box itself is an area 2D. And so area 2D has the ability to detect when things have entered it, but it's not a shape in itself, so we want to give it a collision surface, much like you can have a node, but it doesn't show anything unless you have a sprite node associated with it, right? Compositional design. So here we have our collision shape 2D, which we have set to be, a rectangle. You can set it to be many things. Capsules, spheres, draw your own polygon, whatever. You can make things pixel perfect if you like. Oops, hang on, get out of there. So we have our collision surface for our hurt box. That is the box around the player that does damage. Notice we have a collision that we inherit. So if you see gold values here in your scene, that means they're inherited from another scene. So these are things given to us by character. So our basic physics collision system is there. I wanted the hurt box, so the damage taking system, to be separate. And notice that the collision 2D is, where is our, oh yeah, so its transform is the thing that it's associated with, so it's on layers 1 and 2. But our hurt box is on layer 4. Right, so things that be hit and hurt, we do that through the layer 4 in the physics collision layer system. And you can see we actually have names for those. So there's the level, and then hit hurt. Hit hurt is what I called for. So we have a surface, we have an area 2D, and we have a script. So here's the script for hurt. So first we have a damage value. Is this correct? One moment. Okay. Phew. The hurt box should actually not have damage. I'll have to fix this. There's a little bug here. But we can see it has collision layers, so it is on layer 8, but it's not checking for anything. It's the thing that receives being hit, not hitting things. But we also connect it to area on entered, so when something enters our hitbox, we take damage. So if the owner has take damage method, we take the damage. So I think I actually have hurt and hit reversed in this example. Pardon me, it works. It works in practice. I must have, like I said, cold medication. But this is simply using an event, a signal, the on entered signal. So we register that we connect this script to that ongoing on area entered signal that is part of area 2D. When another area enters it, we call the on entered function. And so we're looking for things that are hitboxes. So I guess when we have been entered, our hurt box has been entered by a hitbox, we then make sure that we have a take damage function on our owner, and that the owner, then that damage value is given to the owner. But we really should be taking the damage from the hitbox, not from the hurt box. That's the error here. All right, and hitbox is inverted. Sorry, that's a hurt box, hitbox. It simply looks for things that are on layer 8. It's not on a layer itself, but it will hurt things on a layer. Yes?
So the collision layer was set to 8, then in the UI it was set to 4. That's like it doesn't have.
What's 4 to the power of 2 to the power of 4?
Oh, okay.
It's bit masking.
Gotcha.
Yep. Good eye. And you can see that here when you hover over it. It says bit 3 value 8. So when you're dealing with it in code, it takes integers that are the values that you want to mask. All right. So same hurt and hitbox. Did you have a question? Okay. So we have hurt and hitboxes. We have a debug window here. It's false right now. Let's see. We turn it on. This is just simply something that you can have a message that's statically above the player. I've used it for things like calculating player positioning, player state, whatever. Has a little script and label attached to it. Enable it if you want to start looking at things. Disable it if you don't want it. And then we have our cheat resource, our cheat res. It's just a node 2D, so it doesn't really have any visible thing, but it has a script attached to it. And this script, when cheat 1 is pressed, calls the player resurrection function. When cheat 2 is pressed, changes the global position of the player. Instant teleportation. Who needs to jump when you can blink? Q flash. F flash? What do you set flash to? All right, fine. Not too many League players in the house. Okay, so that's, I think, the basics, like what you really need to know about player, which, since we've been over this in detail, it makes the boss and follower much easier to understand. So let's open up boss. Let's see, I can do enough hands. Control Shift O brings up the scene open dialog, quick scene open. And so let's go to main, player, boss, top. Great, so now we got the boss open. So we have our boss. You know what this is. This is a collision surface that we have a hitbox attached to. We have 2 overlapping collisions. One is for physics, one is for hurtbox. So you can see here, animation player, collision shape 2D, hurtbox, hitbox, sprite 2D, animation player, or audio stream player 2D. This one's set up a little differently. This one is trying to use the fancy new Unity, fancy new Godot interactive player, which had some bugs in it. But here you can see there's like the yells, which are, you know, our elk yells. So we use all of these inside. As the calls for the elk spirit that drank the blood of the old gods. Or just doing mating calls in the woods of Yellowstone, whatever. So that's the audio stream player. That's something I want to point out. We also have a point light, which is the glowing eyeball. And so if you look in the animation player, particularly if we look into attack, we play the frames, you'll see that we also have point light position and energy. So the point light follows the eye of the player on each frame and gets brighter right as the attack happens, right? So if you notice, the light flashes in its eyes when it swings. So that's how we did it. We simply changed the energy emitted by the point light and its position to match the frames of animation. Right? Fun stuff to do. And now you can see, and where this collision box is unchecked, that's when it's true. When it's checked again, that's when we no longer swing. Just to give that little bit extra juice, right? Okay, so it has a similar set of animations. Doesn't have as many as the player. It actually, the boss doesn't turn around. There's like, so in the narrative of the world, I wanted this corrupted elk spirit that's in this cave to never want to turn away from the sun, right? The pure part of it always wants to see the outside of the cave. And it was a pain in the butt to have to turn the other way. But, you know, you can tell a little story with this as well. That can be a nice weakness of the boss, right? Or if you did have it turn around and it could be depowered or something when it's not facing the outside, or become even more corrupted. But lots of fun stuff you can do here at that boss battle, which is stage 4. Okay, hitbox, hurtbox, you know, same things just before. Sprite 2D, there's a whole sprite sheet here. That's a little hard to see, but you can flip through all the frames of sprite animation to see what we have going on. It didn't have a jump animation, so for jump, I had it call on the spirit of the weather to pull itself in the air and do a thunder crack when it jumped. So, you know, get a little inventive sometimes when you get a limited sprite sheet. Great. I think we've been over everything that's important. The boss, let's look at its script real quick. You can see how it's different from the character. It's got health. It has a command list. So something important to see here is when we are in the boss encounter trigger, this trigger is that volume right inside the boss's room. When the player's body enters it, it starts the boss battle, it moves the camera, and it does a few things. It calls the engage command, so that then triggers the audio script. Time to die, demon, or something. Makes the boss sprite visible. Is all that it is before that is a glowing orb, its spirit, and then it summons itself, right? So the first thing we do is we load that boss up, its command list, with a bunch of commands that are durative. They take time, so that means we know when they end, so we can go on to the next one in the queue. So summon, idle, jump, 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 attack, jump, attack. Move left for 2/3 of a second. Right, left, right, attack. Left, right, attack, command, dialogue. I was going to get rid of this dialogue. I just wanted that so so you could see how it works. It's actually, it disrupts the flow of combat. So now that you've seen this, let's just take a quick look at the boss battle.
Let's see what you've got.
So now you can see all these parts coming together. Damage animation. Damage animation. And then there was the last one. Right, so we made a tiny little boss battle script. Now for you in stage 4, you're gonna make a more comprehensive one. You could use all these basic mechanics, add in a few more, but also make it so it doesn't end, right? When the queue empties, refill it, right? Until the boss dies. Okay, 4 minutes left. Let's see what we can get through here. We'll just cover the rest that we don't get through in discussion section. There's just a lot to this project, a lot of little edge cases that you as gameplay programmers will probably want to know. And when you're making your own game, like this stuff is nice. And feel free to use any of this stuff in your final projects. Queue free. So this actually, the queue free here is important because queue free removes a node from the node tree. So we get rid of the trigger, so we don't accidentally double trigger it. Did you have a question?
So for stage 4, we just have complete freedom with what we want to do with the boss battle.
Impressed me. Stage 4, I like having the last stages on these assignments be something like creative and open-ended. There are some like basic requirements that I put inside the description that you should hit. Some people are more creative than others, but this is where people do some really fun stuff. Like for the last class sessions offerings of this, when you had like the pirate command, like people even got their friends together and sang like sea shanties and put that into the game, right? So do your best to yell elk shanties. All right. So we're talking about back to the boss script. So this boss script, we have basic velocity, we have process. So this is important, and you'll see this in the description. This is how we're handling the command queue. If the command queue has something in it, so its length is greater than 0, we call execute on the first one, on the one in front. And we do it until it's done. When it returns the done status, then we pop it and go on to the next one, right? This engine that makes the command queue run, because we set up our execute functions in such a way, this is a nice, simple, easy, debuggable, understandable way to make that process go, to make the engine of commands run. And if there's no thing in the queue, idle, right? Take damage. We have our death function here. And this is what I like. So we use yell3, but what we also do here is while we're going through and taking damage, we call manage desperation. And this manage desperation function gets the boss audio channel, which you can see the audio channels here, the audio bus, and we have boss here. And boss has a pitch shift modifier. And so what we do is we go through here, we get a, we go through and we find which one of those, because we can have multiple effects on here. We just want to find the ones with the pitch shifter. And we get a reference to it. And then if that reference is something we can use, if it's enabled and not null, we then change the pitch scale. So what we're doing is taking the pitch scale to 1, which is what it's normally at, and then we add, fractionally, we take the 100 minus the health divided by 100. So when health is 100, the pitch bend is 0. When the health is 0, the pitch bend is 1. And so that basically like doubles the perceived pitch, makes it like an octave higher, I think is how it works. And that makes it sound like it's taking damage, it's desperate, right? It's a little effect with a buff that had like a pretty big payoff in the final boss battle. So feel free to check this stuff out. Callback function for when it's being summoned and jumping, so we know to play the correct audio clips, like blast and yell 1. Yeah, I think that's the entire boss script. I think we've covered all of that. What we have not covered, I know it's 3, which we'll cover in just a moment, is the poison zone, the follower, and the structure of commands. And I'm waiting for the structure of commands to talk about. I've sort of like saved that because it's integral to the assignment. We talk about the assignment, we discuss the command pattern, and all that last bit will lock into place. All right? Okay, well, I'll see you all at discussion section. Thank you. Take care.